Pythagorean Theorem. Before we start learning the Pythagorean Theorem, it's interesting to know where the theorem first came from. About 2,500 years ago in ancient Greece, carpenters were looking for a more efficient way to build their houses. They wanted the walls to be square to one another all the time, and they didn't have good tools for doing that. They devised a method with a rope that would help them make square corners on all of their buildings. They would take a rope that was divided into 12 equal lengths, and they would tie it into a circle. I've got a string here that's divided into 12 equal lengths. Each of these lengths is 6 inches long. Then they would have 3 carpenters each grab a knot. They didn't grab just any knot, they grabbed specific knots. One carpenter would hold a knot, and the second carpenter would count down 4 spaces from that, and he would grab the second knot. The third carpenter would move down 3 spaces, and he would grab the third knot. They would all back up and pull the rope tight, and they would notice that one side was 3 units long, one side was 4 units long, and the third side was 5 units long. By doing this, they made a square corner. They would tack the rope down to the ground, and they would build their house so that the walls were square right into this corner, this right angle. And they found as they went on that it didn't really make any difference how they divided up the rope. Perhaps the first guy would only come down 3 knots, and the second guy would come down 4 knots, and they would still have sides of 3, 4, and 5 that would make a right angle. They discovered that if you didn't do it in exactly that order, bad things would happen. If they didn't count out correctly, they would get a triangle that looked like this. And that wouldn't have any right angles in it. So the proportion always had to be a side of 3, a side of 4, and a side of 5. And in that way, they would always guarantee a perfectly square corner that would help them to build their houses. A mathematician at the time, Pythagoras, thought this was an interesting phenomenon, and he started studying right triangles to see if perhaps there were more relationships than were just found in the 3, 4, 5 triangle. And he discovered what we know today to be the Pythagorean Theorem. Pythagoras set about investigating right triangles. He only worked with right triangles. He always wanted them to have a right angle. He didn't care what their orientation was, as long as they had a right angle in the triangle. He identified the parts by labeling them. The sides that connected the right angle he called legs. So this side is a leg, and this side is a leg. Because they connect the right angle, both of these are legs. The side across from the right angle, the side that doesn't touch the right angle, he called the hypotenuse. He quickly found that the hypotenuse was always the longest side of the triangle. But that wasn't sufficient for Pythagoras. He kept investigating and trying things, and what he found out was there was a unique relationship in a right triangle between the legs and the hypotenuse, and that relationship was known as the Pythagorean Theorem. And we know it to be this: if you take one of the legs and square its length, and take the second leg and square its length, and you add those two amounts together, you will get the square of the hypotenuse. So in other words, in a right triangle, and only in a right triangle, the leg squared plus the leg squared equals the hypotenuse squared. Now we have some right triangles up here on the board, and we want to identify which ones are the legs and which one is the hypotenuse. First example, we see a right triangle, and the first thing we need to do in any right triangle is identify the parts. We have the side C labeled as the hypotenuse. We know it's the hypotenuse for 2 reasons. Number 1, it's the longest side in the triangle. And number 2, probably more importantly, it's across from the right angle. So the side across from the right angle we're going to refer to as C. The hypotenuse will be referred to as C. Now the 2 sides that connect the right angle are the legs, and those are A and B. And if we go by our formula of leg squared plus leg squared equals hypotenuse squared, and we know what these parts are, we can rewrite that formula as A squared plus B squared equals C squared. It's important that you remember when you're using this particular formula that C is always the hypotenuse or the longest side of the triangle. A squared plus B squared represents the sum of the squares of the 2 legs, and C squared represents the square of the hypotenuse. In our specific example, we've labeled the legs as 3 and 4, and we want to find the remaining side or the hypotenuse. I know that A squared plus B squared is equal to C squared, and these represent the legs. So I will be able to solve this triangle by saying 3 squared plus 4 squared equals C squared. I know it's the hypotenuse that I want to find. When I square these numbers, I get 9 plus 16 is equal to C squared. And when I add them together, I get 25 is equal to C squared. Now when I'm solving this equation, it's a pretty simple equation to solve. I just want to take the square root of both sides. So I'll take the square root here. And when I do that, the square root of c squared is c, and the square root of 25 is 5. What that tells me is the length of the hypotenuse is 5 when the lengths of the legs are 3 and 4. In fact, 3, 4, 5 was the very first combination that was discovered by the ancient Greeks when they were doing right triangles. It's called a Pythagorean Triple. There are other numbers that are as famous as the 3, 4, 5. They are 5, 12, 13, and 8, 15, 17. And in each of these cases, as well as many other examples, if you square the first number and square the second number and add them together, they will equal the square of the third number. 5 squared plus 12 squared is equal to 13 squared. In this case, 8 squared plus 15 squared is equal to 17 squared. In our third example, we have a right triangle, and it's important to establish that it is a right triangle because we know the Pythagorean theorem only works for right triangles. We have one leg that we don't know, one leg that we do know, and a hypotenuse that we do know. We know the Pythagorean theorem states that a squared plus b squared equals c squared, where a and b are the legs and c represents the hypotenuse. A we have defined to be 8 feet, so we can say 8 squared. B, the other leg, is unknown, so we have to leave it as a variable. And C, the hypotenuse, is defined to be 10 feet. So we have 8 squared plus b squared is equal to 10 squared, and we need to solve this equation. If I square 8, I get 64 plus b squared is equal to 100 when I square the 10. Now in solving this equation, I'm going to use my good equation solving skills, and I'll subtract 64 from both sides. When I do that, the 64 is gone, and I have b squared is equal to 36. And since I know b squared is equal to 36, what I want to be able to do is solve for b, and I do that by taking the square root of both sides of this equation. And that way I find out that b, the missing leg, is equal to 6. Since I'm in feet, my answer should be labeled as well. The missing leg is 6 feet long. In our fourth example, we have got to establish first that it's a right triangle. We see there's a right angle marked. And we know the two sides that connect the angle. So we know that those are the legs of the triangle. The Pythagorean theorem states that a squared plus b squared is equal to c squared. When I substitute in my numbers, I will have 18 squared, that's one of the legs, plus 25 squared, that's a second leg, is equal to the hypotenuse squared, or c squared. When I start solving this equation, I'm going to square 18, which is 324, and square 25, which is 625, and I'll get c squared. When I add these two together, I get 949 for the total as equal to c squared. Now I know that just like in the previous problem, I need to take the square root of both sides. In this case, I don't know the square root of 949, so I'm going to use my calculator to find that out. I put in 949, and I access the square root key by hitting second square root. When I do that, I find out that c is equal to 30.81. It's approximately equal to 30.81 because I rounded off the numbers in the calculator. Now I want to come back and I see that my problem was labeled in inches, so I'll want to label my answer in inches. And I see that my answer to this triangle tells me that the hypotenuse, the longest side of the triangle, is 30.81 inches. Using the Pythagorean theorem will enable you to find a missing side of any right triangle.